Okay, welcome back. So now what I did, I copied and pasted our stack demo file from the Moodle site right here into Visual Studio. So you at home, you want to start a brand new project, start a new source file, and copy this into your Visual Studio so we can test it. If we can test it, then we can probably add or remove some methods. In fact, our project number 2, or assignment number 2, will be based on the concepts we are going to discuss now. So here it is. So we have a couple of libraries here. So we have our stack ADT abstract data type right there. We have some virtual methods here. So that's our parent class. We talked about this parent class. So we have 1, 2, 3, 4, 5, 6 methods. These methods must be implemented in our derived class in stack class, which I'm highlighting here, stack type. Okay, so let's scroll down. And let's take a look at our stack type. So here it is. Stack type is inheriting from stack ADT. So this is how you can show if this one is a derived or child class and this one is a parent class or superclass. And this colon here, this operator, builds that relationship between our child class and parent class. Okay, so if you're at home and you're trying to, you're wondering how did we build the relationship, and this is how you build the relationship. So you have the name of the class stack type. That's your class which you are going to build here. And this class stack type is based on stack ADT. And if you want to visualize this relationship, this is what it looks like. Stack ADT looks like over here. It might be difficult to capture there, but what I have over there is the parent class has all the methods which must be implemented at the child level or derived level. So I have 3 variables here, which we discussed in our PowerPoint slideshow as well. We have a variable for maximum stack size. We have a variable for stack top, just to figure it out, what's the top value. And we have a variable, so we can actually, a pointer variable, so we can actually track or traverse our stack in order to access it, in order to build it, in order to add it, remove it, and all those kind of things. Our first method here, which must be implemented, is stack, initialize stack. Let's see what initialize stack looks like. Really, really simple method. Okay, so I want to initialize stack. And in fact, all you need is a 1 line of code. I just added the second line of code just for you to see it. You don't need the second line of code in your project number 2. So I leave these lines of code for you to see what the value is. But at home, when you're building assignment 2, all you need is this line of code, stack top equals to 0. So I'm saying whatever data you had, I just want to reinitialize these values. Let's say you had previously 5 or 6 or 10 different values in that stack. Just reinitialize your stack top to 0 and ignore the data you had previously. So that's what, and you might say that's not a pure way to delete the data. I agree with you. So we are not deleting the existing data. We are not removing the existing data in this case. All we are doing is changing the value of the initial of your stack top. So if you had stack index 2 or 3 or 4 other elements, they are in place. We are not physically removing the data. So I agree with you. All right, so let's look at the print method. If I know what is my stack top, I have 4 elements or 400 elements. If I know the value of my stack top, so I can actually run a loop from 0 to that value. 0 through 4 or 0 through 100 or 0 through that particular value. So my loop is going to run through, and all I'm doing is go to the 0th element, display the value. Go to the first element, display the value. Go to the second element and continuously do that in order to display the entire stack. Really simple method. Okay? This print method did not exist in our parent class. Parent class did not dictate us to have a print method. And in some exercises, you will see that parent class might dictate that you must have a print method. So here it is not. So we are creating our local method called print. And we already have discussed our empty stack and our full stack. So very quickly, I'll go through these. So if I want to check if it's empty, if the stack top equals to 0, it's empty. If the stack top is equal to maximum stack size, it means it is full. Okay, so our empty and full methods. All right, so let's say I want to add a new item. So this is something we have not talked about yet. So I want to add something. So user tells you I have new item to be added. What type of item? Integers, doubles, characters, strings, maybe another complex data type? Absolutely. You can add any type of data. Because we have template, it allows you to add any type of data. In fact, that was exactly what we did in assignment 1, that you figured out how you can actually send other types of data. And most of you did successfully. So because it's a template, doesn't really matter. And our class is designed to handle any kind of data, any kind of incoming data. So whatever data it comes in, this data is of this type. This data is of this type. What type? Could be an integer, could be double, could be string, any kind of data. And it is sent as a reference, which means I am not making a copy of the new item. I'm sending the address of the new item. So let's say user gives you this new item. To keep it simple, let's say user gives you value 35. So this 35 resides in the RAM. And this 35, it's sitting in a RAM with some address, some location address. So I'm sending the location address. So this method is referring to the same location address. I'm not sending a duplicate copy. I'm sending the location where the original value was residing. And notice that the push method is a void method. It's not designed to return anything back to you. Okay, so first thing I check is the stack full? If the stack is full, I should not be adding anything else. So I check if stack is not full, then I should have the ability to add. And I'm saying list stack top equals this new item. This new item added there. So let's say we have 4 items. So now I'm going to increment to 5 items. That's what I do. Stack top plus plus. And if it was already full, I should say we cannot add anything to the stack. Really simple method. And this one is not really necessary. I'm just adding this one just to show you once the value has been added to the stack, I can quickly look at the stack top. If it was 4, it will show you 5, and so on and so forth. In your program in assignment number 2, you can test it that way. But once you're satisfied you're getting expected results, you can remove this line and you can remove the pause. I just added these 2 lines there. You guys are okay with the push method? Really simple method. Let's look at the pop method. Or let's look at the top method first. So if the stack top is equals to 0, it means stack is empty. If it's not equal to 0, it means it's not empty. So I just want to return stack top minus 1, the value of that particular element. Return it so we can actually display it, the top value. Now the pop is for removing something from the stack. So when I want to remove something from the stack, first thing I'm checking, if it's not empty, let's say we have stack of 4 elements. I want to remove the top element because in LIFO, last in first out, we can only remove from the top. So if it's not empty, I want to say stack top minus minus. So previously the value of stack top was 4, and I make it 3. So this one becomes 3. By chance, if it was empty, I cannot remove from the empty stack. And again, I just added this line of code just to see the new value of stack top. I have a couple of constructors here. So I have the first constructor here. So this constructor has an ability to take the value of the stack size. However, if the user does not provide me the stack size at the time of the creation of the object, I'm expecting some size from the user. User does not provide me that. Then I want to leave a default size. This is called default. There's a term. This is a default value for that particular argument or default argument. So I'm saying if you do not provide me the stack size at the time of the creation of your object, the default size will be 100. And this is how we implement it. So if the stack size, let's say the user creates stack size -1. That doesn't make any sense. So I'm checking if it's less than 0 or equal to 0. If you provided me a value which does not make any sense, I'm going to say size of the array to hold the stack must be positive, must be something which makes sense. So I'm going to creating an array size of certain value, the default size. Maximum size is 100. Okay? So this can be done just to avoid any complications if the user does not take certain actions. So you can actually have a code like that one. You can also say, I don't want to have any default value. I can check in other ways, and if the user does not provide me any positive values, then I'm not going to create any stack. Sure, that can be done as well. So you can remove the word equals to 100. If the incoming value is 0 or negative value, then you can simply say, you know what, I'm not creating any stack for you because you did not provide me any positive value. If the stack size is greater than 0, let's say the user provided 50, not 100, 50. So whatever the incoming value will be, is coming in, so it will be set to maximum stack size. So this time it's the maximum stack size is not going to be 100, it will be whatever the value provided by the user. And then we simply display that one. In your code, once you're satisfied, you don't have to display it. Here I'm just leaving that line of code just to see if it really implements the incoming stack size. And when it's a brand new stack, we just created a brand new stack with certain size. There's no data. We have not called the push method yet. So that's why the stack top will be 0, which means we have no data. The stack is completely empty. And we also create the first node. The first node is being generated here. So I'm saying the maximum stack size, or I should say the entire list is being generated here, because here we're saying maximum stack size, let's assume it's 100. So I'm creating a list of 100 elements. As you can see, new item, the maximum stack size. The second constructor, let's look at the second constructor. The second constructor accepts another stack. So the second constructor takes an argument as another stack. So another stack comes as an argument. So I'm going to take this stack, send as an argument to copy. So our purpose is you have one stack, you want to take another stack and copy them. Copy the second stack to the first stack, or copy the other stack to this my local stack. That's what the goal is. So here, before I copy this one, if I have an existing stack, I want to make it null. I want to clear the list. Clear the list so we can make a copy from incoming stack to the existing stack. Then our destructor here, destructor deletes the list. Before we exit the program, we delete and release the memory back to the operating system. There are a couple of other methods. One is equal method, one is equal method, and I'll talk about these operator overloading. But before I do that, let me jump directly to copy stack. And the copy stack, let's talk about copy stack. So copy stack takes an argument of the other entire stack. Now you say, how do I call copy stack? Right, let's say you have stack 1 equals stack 2. So when you are saying, I would like to copy this entire stack 2 to stack 1, there's an equality. I'm sorry, there's an assignment operator. So I would like to assign this value these values to this stack. This assignment must be overloaded. This must be overloaded. And we'll look into that overloaded assignment operator in a second. But let's take a look here. So this is the entire stack. I'm bringing that stack as an argument, and I'm just making sure my list is clean. If I had something in the list from the previous processing, clean the list, delete the list. And maximum stack size of my local stack, which in this case is stack 1, is the maximum size of the incoming stack. This other stack had the maximum size. Assume it has 50 of these elements. So I'm taking the maximum size of the other stack, assigning to the local stack, because I'm going to make an identical copy. Then I also take the stack top, whatever the stack top of this other stack was, I want to assign to the local stack top, because our intention is to make an exact copy. Then I would like to create a new list. Whatever the incoming stack value was, I would like to make a new list. So let's say we have 50 elements, so make a list of 50 elements. Okay, rest is really easy. Rest is really easy. So we run through 0 through the max stack top. Let's say we have 4 or 5 or 10 elements or 50 elements. So we say whatever the list 0th index of the other stack was, assigned to the 0th index of this list. First element is assigned. Second element is assigned. So in that when we cycle through, all the elements of the other stack will be copied into the local stack. So that's your copy stack. However, there's still one problem in this program. The problem is it's not easy to indicate certain operators. These operators must be clarified at the coding level. And let's take a look at this equality, the assignment operator first. The assignment operator must have its own body in order to clarify to the program. Otherwise, program will be confused that it's not a value like 5, x equals to 5. It's not a simple value. It has so many methods and so many variables, you cannot simply say stack 1 equals to stack 2. So this must be clarified. And this is a standard C++ method operator, so you need to use a keyword operator equal whatever operator you want to overload and whatever type of data. So in this case, let me just scroll a little bit. So here's my other stack. Let's put it here, other stack. Here's my other stack, which is being sent as a reference. It must be sent as a reference. It cannot send as a value, because other stack is not a simple value. It must be, it resides somewhere in the memory. It has so many methods and so many data variables. So I have to send as a reference, and of this type. And this other stack is part of this stack type. So stack type and type of data. This is the type of data. So I send that as an argument. So other stack, and notice that what exactly that means here. How do we read this line of code? If we understand this line of code, it will make sense for us. Help me understand how do you read this. This looks like a strange line of code. I'm referring to here. Hopefully you can capture on the camera. If this not equal to ampersand sign other stack. Help me, guys. Help me. So we know other stack is some kind of stack. I'm using the address location of where this other stack resides in the memory. So that's the address I'm referring to. So I'm checking if this is not equal to exactly the same location. So I'm checking if this stack, this refers to the local stack. If the local stack and the other stack, they are not exactly the duplicate copy. I'm just ensuring that. They are not pointing in the same direction. They are two separate locations. They are two separate locations. They are two separate stacks. So you want to leave this one just to avoid self-copy. Self-copy. So this will be a self-copy. So this statement actually allows you to avoid self-copy. I should have put statement there to avoid self-copy. So this allows you to avoid self-copy. Yes, we have a question.
So when the ampersand is used in front of other stack, that's referring to its location?
Its location, its address. That's right, yeah. Because I cannot, because I'm saying this address, and by the way, this pointer, this is a pointer, this is a keyword. Whenever we use the keyword this, it means the address of the local object. So this means address of the local object. So address of the local object is not equal to the address of the other object. So that's how you can read it. I know it's kind of confusing, but do we have this object or this keyword in Java? Yeah, we do. Yeah, we also have in other languages. So it's an address of our local object. So sometimes we use this one in order to, and it's faster that way. It's more efficient. If that's not the case, then call the copy stack. Once you have successfully copied everything, it brings it back, and then you say return the address of this newly copied object. So that's what I'm returning. Return address of this newly copied object. So this address will be returned, and you can capture that address to do something with it. Let's look at the equal, which is equality. We want to check equality here. Again, your argument list will be similar, so your signature will be similar. And by the way, later on you will also find multiplication, division, modulus, less than, equal. And in fact, just to tell you the significance of these operators, many years ago, I was actually in the interview, and in the interview committee, there were 6 or 7 people. They asked me to go on the whiteboard and write this exact signature, how to overload an operator in C++. So if you know that bool operator, this is a keyword, whatever operator you're trying to overload. And in the signature, you can make it constant, whatever the object you have, type of object, and the incoming object. So this is my incoming object. I would like to check if they're equal or not. So this is what I want to check. If stack 1 equals stack 2. That's what I'm trying to do here. Stack 1 equals stack 2. You might not be able to see on the camera, but if stack 1 equals stack 2. Now, these stacks are not simple variables. They're complex objects. So we must tell our C++ compiler what is my intention. And this is where the intention is. This is my intention. So the compiler can clarify, negotiate that particular line of code. Otherwise, compilers say, you know what? I don't know what you're talking about. I don't know how to resolve this issue. So this is the resolution for the compiler. So compiler says, okay, you provided me some operator overloading. You told me how to handle that situation. So whenever it comes to a situation like this, where you're using equal, or less than equal, or greater, or less than, then I'm going to go and look at the definition. So here, this is my other stack coming in. So I'm checking if this local object or local stack address, this is the local stack address, if it's equal to the local area, if they're exactly pointing in the same direction, it means return true. It means they are exactly copied on the same location. Otherwise, I'm going to start checking the equality. This one is, you want to leave this check there. It is quite possible this local stack and the incoming stack, they are exactly referring to the same memory location. If not, what do we do? If not, then we'll start checking a few things here. So we go to the else part. In the else part, we check the other stack top, the stack top of the other stack. If it's not equals to the stack top of the local stack, return false. If this one is 3, this one is 4, they are not equal. We don't need to waste our time to do other things. Do you see what I'm saying? We added 3 elements here, we added 5 elements there, or vice versa. They are not equal. If they are not equal, don't waste your time to do anything else. Simply say return false, they are not equal. If that's not the case, if the stack tops were equal, then let's go and check a few other things. What do we need to check other than that? Let's check each individual value of each index. We want to go through the cycle and compare first index of each stack. So we go through this one, stack top. Let's say stack top is 4 or 5 or 10 or 100, doesn't matter what value is. We check the 0th index, and we say if the 0th index value of the local list or local stack is equal to, not equal to, the other stack list of 0th index. If the first elements do not match, return false. If they match, return true. Then check the second element, third element, fourth element, fifth element, 100th element, 1000th element. If every single element they match, continue to return true, and at one stage, if they are exactly identical, it means equality applies. Equality applies. If one of the elements were different, the false will be returned and your program will end right there. Yeah.
How come the return true isn't outside the for loop?
This return true?
Yeah.
You can actually put it, if you want, you can put it else there. But because if this condition is false, naturally you will come to this line of code.
Great. So then wouldn't that just break out of the loop if you return?
No, because we are still in the for loop. We're still in the for loop. So, yeah, so that's why. So we still continue with the for loop. So this is what we do. And let's look at our main function now. Main function. So I declared 2 stacks, stack 1 and stack 2. And I declare them as integers. Can I declare this as chars? Sure. Just remove the word int and put chars there. You'll have the ability to declare chars. And your program will work flawlessly. No difference whatsoever. All right, so I initialize my stack. I make sure my stack is empty. And I add some values because these were integers. So I have the ability to push some data. So 23, 45, 38. Those are the values added. And I verify it. I print it. Let's go ahead and print it. Let's see what happens. You might see some additional additional code there. Let me see if I can bring this one closer or maybe further. I think you can see over there. So when I declared my stack 1 in my class, I have a line of code, cout maximum stack size. It shows me 50, and for the second stack, also 50, because I declared 2 stacks, stack 1 and stack 2. Then also in that one, before I added any data, before my first push, I'm displaying the stack top. Initially it is 0. Then I probably add some data. And when I add the data, then I would like to see some value there. And press any key to continue. When I hit continue, now stack top becomes 2 because I added the second value. First I added right there 23. Then I added 45. Then I added 38. So stack top will become 3. Stack top is 3. So this makes it 1. This makes it 2. This makes it 3. So again, I left these so you can actually gradually look at how the program is behaving and functioning. So that's what I recommend when you're at home. I know some of you sent me a message around 11:50, 11:55 last night, and you said, you know what, I don't know how to install Visual Studio. And I was pushing for the last 2 weeks. In fact, a week before that one, install a Visual Studio. Come to our lab. At this stage, when you're taking data structured class, you should be able to figure it out. If not, that you use our labs here. We have lab in LAC campus, also for our online students, PCC campus. You can use our labs here anytime. Of course, they are not open around 11:50. So if you were struggling at 11:50, I was asleep. I go to sleep around 9 p.m. for the online students. If you want to send me a message after 10:30, so I'm not awake, I'm not checking my messages. Now you can say, this is an online class. It is supposed to be 24 hours. I agree. But that doesn't mean there's an online help available 24 hours. All right, so here we added these, and I put a lot of system pauses. So I recommend the same thing to you. Put a lot of system pauses just to see how the program is behaving. Please do not go any further if it's not making sense to you. So I got a message last night, very late. This morning I checked that I don't know how the program works. I agree, if it doesn't work, you don't understand it, the day of the assignment was due, that's not the right time. You should have asked me that question a few days earlier, so I could have helped you, maybe have met you online or somehow. So you want to start early. For assignment number 2, start early. How early? Today. Start today. For online students, start your project number 2 right now, today. And in this assignment number 2, you will see it's not very challenging. The programs are not very challenging. At this stage, when you reach data structure classes or advanced computer science courses, you already have built the foundation. What you're trying to do is see if you can implement some of the existing code and modify it, add few things, add few methods, and figure it out, because you are becoming a problem solver. That's what you're trying to do here. All right, so if I want to print the data, which I have added, all the elements I added 1, 2, 3 elements. As you can see, push, 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 and that's the data. I call the print method right there. The print method is going to go through for loop, and it shows me all the values in that print method. Okay, once I'm satisfied with that, I'm assigning the entire stack 1 to stack 2 in the next line of code. Right there, guys. I'm assigning the entire stack 1 to stack 2. And I just explained to you a few minutes ago how the assignment works and how the equality works. So I'm saying take the entire stack 1, assign to stack 2, and then compare them. If I'm making a fresh copy of stack 1 to stack 2, I should be getting this message. Stack 1 and stack 2 are identical. Otherwise, if there's a difference, it will say there's a difference between those two. Okay, so if I'm running this program at home, just to understand, I would actually probably copy the system pause and put the system pause here. Actually, let's do it. I'll put the system pause here so I can go step by step. I'm going to read on the program. And then I say stack 1 and stack 2 are identical. And that's exactly how it was expected. The stack 1 and stack 2 are identical because I just made a fresh copy of stack 1 to stack 2. Then I pop something. I want to see if the pop works. And let's put this one here. Right here. So I'm calling the pop method. Pop, remind me what exactly the pop does. So it's going to remove which data? It's going to remove 38. Absolutely. It's going to remove 38. So if I say pop one time from stack 2, I'm popping stack 2. So because I made a copy of all these elements to stack 2, I'm going to remove 38. Then guess what? I'm pushing 38 again. Just to show you, you can pop it and push it. Then I compare again. Are stack 1 and stack 2 are equal or not? So let's check it out. So if I pop something and push it again, and it says, let me try again. Can I run it again? Yeah, it's basically when I'm pushing and popping, I'm displaying the local values. That's why you see some additional stack top and all those things. I'm just displaying the locally. That's what I was highlighting earlier. So after pop and push operations on stack 2, stack 1 and stack 2 are still identical because I pushed and popped a value, similar value. Then I go one step further. Then I say, you know what? Let me see if I can show in my code something different. So this time I push stack 2 with a new value, 11, which does not exist in stack 1. Then I compare them. This time I'm expecting it will say your stacks are not equal. So let's check it out. So this time when I run it, it says stack 1 and stack 2 are not identical right there. I think you can see on the camera as well. So after you pushed a new value into stack 2, a value 11, now they are not identical. Okay, so we understand how to build stacks. We have the methods how to build stacks. We have the methods to compare them. We have the methods, we understand how the push works, how the pop works. We have methods to how the print works. It's all given to us. It's in your book. Every single method I have taken, I just copied and pasted from the book. It's in the book. During your chapter 17, when you're reading chapter 17, you will see exact definitions or implementation of each one of these methods in your book. I actually went step by step, copied and pasted. Just modified a few things here and there just to make my own version. What I'm saying is, now can I do something additional in my stack class which I'm which I'm using here? Can I add another method? By the way, this I showed you last time. If you're satisfied with one of the methods or multiple methods, you can minimize them. So it allows you to make it more readable. You can minimize a bunch of these methods, especially if your method is fully implemented and you're satisfied. You know that you are not going to add more things to that method. You can minimize all these methods. Things like pop and top and push, these are the same things. You will not be making significant changes to those methods. So here you might not see in the camera. All I'm doing is minimizing it, and I'll show you in a second on the camera as well. And here's my class stack type. Here's my class stack ADT. All right, I'm going to show you on the camera as well. So here's my class stack type. I just minimized it. You can expand it by clicking the plus sign, or by clicking the minus sign. You can actually collapse them or expand them based on how you want to view it. Sometimes you want to have this kind of view. So if you have hundreds of methods, so some of the methods have been tested and verified, you're not planning to modify those methods, go ahead and collapse them. Go ahead and collapse them. In that way, you accidentally do not change them, or you don't need to have too many things visible to you in your program. So if I have my stack type method, which we tested and verified, it works. What if I ask you to add something to stack type? Another method. Do you think you can handle it? Say yes. Yes, good. Also for online students, you guys can add a method to stack type. All right, I want you to add a method, and this method is on our Moodle site, Assignment 2. Assignment 2 tells me work on exercise number 3, page 1261. That's our assignment. No, did I say assignment 2 or 3? Assignment 2. So that's our assignment 2, exercise 3 from page 1261. Let's go and open our book. Our book, let me open a book here. (1261). I'm going to jump directly to 1261. All right, so I'm on page 1261. Page 1261, exercise 3. It says add the following operation to the class stack type. Do I have stack type? Yeah, it's on our Moodle site. It's in your book. If you don't understand what we have on the Moodle site, it's in the book. Void reverse stack. It's giving you the signature of the method as well. It's giving you exactly what the signature looks like. Other stack comes in as a stack type. The name of the method is reverse stack. Just by looking at the definition, it tells me a lot. It tells me everything about that particular method. And this method, this operation copies the elements of the stack in reverse order. So let's say we had 23, 38, 45, 38. We had 3 elements in that stack. You need to reverse them. What do we mean by reverse them? So if we have a stack, we build a stack like this. We had, let's say, 100 elements, but in our stack, we have some elements here, 23, 45, and 38. Let's say this is what we have. Our job is to reverse these. So, and in fact, when you display them, you don't need to display. Assume that you don't need to display the empty elements. You just need to display, just for sake of understanding, you can still have a size of 100. That doesn't matter. But 23 will become the top element, 45 remains there, and 38 becomes the bottom element. So basically, you are placing these elements in this order. You want to reverse it. So this operation copies the element of a stack in a reverse order. So you consider you have stack 1 and stack 2. We already have in our assignment, in our Moodle site. So when you call reverse stack and you send the other stack to the first stack, so the second stack will be captured as other stack, and you need to figure it out how to reverse your stack. So the copies the element. That's what it does. It copies the elements of stack 1 onto stack 2 in reverse order. That is, the top element of stack 1 is the bottom element of stack 2, and so on. The old contents of stack 2 are destroyed. If we assume if we have some old contents, and stack 1 is unchanged. So you do not change stack 1. You keep the stack 1 the way it is. Write the definition of the function template to implement the operation reverse stack. So that will be our assignment 1. Assignment 2. This assignment will be due October the 15th, which is the Sunday of this week. So there'll be no lecture on Wednesday for our on-campus class. So if some of my online students would like to come, there'll be no lecture. So we'll only have a lab if you want to come and attend the lab. But our goal is to work on this project this coming Wednesday. Our next lecture will be next Monday, which is 16th. So on 16th, October 16th, I'll be making another recording, and I'll be uploading the recording for Qs. So my focus will be Qs for the following lecture. All right. Thank you, guys. And I'll see you next week.